In this lecture, we take another example of partial differentiation. Now, if x is equal to u tan v and y is equal to u sec v, then prove that partial derivative of u with respect to x when y is treated as constant into partial derivative of v with respect to x when y is constant, which is equal to partial derivative of u with respect to y when x is constant, and partial derivative of v with respect to y when x is treated as constant. So here, if we see all the terms, we have four variables u, v, x, and y. And now here, if we see the expressions, what we have to prove it. So del u del x, del v del x, del u del y, and del v. This is, I think, okay. Del u del y and del u del v del y. So now here, if we are taking del u del y with respect to y, what it means, x is constant, x is treated as constant. So this is not the extra notation. Here we are using notation y because there are four different variables. So let us try to prove this result. So we have given that x is equal to u tan v. Let us give it equation number 1. Y is equal to u sec v. Let us take it is equation number 2. Now here x and y are dependent variable. If we see in this example, x and y are expressed into the in terms of u and v. But in our example, in our question, we have to write down u and v in terms of x and y. Here, x and y are given in terms of u and v, but we have to write down u and v in terms of x and y. So let us do some calculations, and we will try to convert this expression in such a way that u and v will be the dependent variable and x and y will be independent variable. So let us do the first thing, squaring 1 and 2 and subtracting 1 by 2 we have. So what we are doing, we are squaring 1 and 2 and we are subtracting 1 by 2. So shall I write like this? Just look here, y square minus x square, which is equal to u square sec square not x, it is sec square v, and it is tan square v. So we know that what is sec square x minus tan square x? This is nothing but 1. So we are getting y square minus x square equal to u square. Since sec square x minus tan square x equal to 1, or we can write down u is equal to root over y square minus x square. Now the value will be either plus or minus, but here we are considering that positive value. So u is equal to root over y square minus x square. Now similarly, dividing 2, now dividing 2 by 1, what we have? We have y by x, which is equal to u sec v upon u tan v. So this u and u will cancel. Sec v is nothing but 1 upon cos v, and tan v is nothing but sin v upon cos v. So this cos v will cancel and we have 1 upon sin v. So v is equal to, okay, sin v is equal to x by y. So v equal to sin inverse of x by y. So clearly here, x, y were the dependent variable in the given question. And now we have converted u in terms of y and x and v in terms of x and y. So we can say that u and v are dependent variables and x and y are independent variable. Let us do the next step. Now what is our aim? Our aim is to find out del u del x with respect to when y is constant, del v del x when y is constant, del u del y when x is constant, del v del y when x is constant. Okay, so let us try to differentiating u and v partially with respect to x and y. We have del u del x when x is y is constant. So u is equal to root over y square minus x square. We know that what is the derivative of root of x. Let us just try to find out what is the derivative of root of x. This is nothing but 1 upon 2 root x. 1 upon 2 root x. How we can write down? It can be written as d dx of x to the power 1 by 2. And if we find its derivative, 1 upon 2 x to the power 1 upon 2 minus 1. So 1 upon 2 x to the power minus half, or we can write down 1 upon 2 x to the power plus half, or we can write down 1 upon 2 root x. Right? So same thing. Now here, instead of x, we have root over y square minus x square. So 1 upon 2 root y square minus x square. And again, the derivative of y square minus x square with respect to x is nothing but minus 2x. It is minus. So this 2 and 2 will cancel. We have x upon root over x square minus y square. Okay. Now in the same manner, so what is the partial derivative of u with respect to x when y is treated as constant, which is equal to x upon root over x square minus y square. Similarly, the partial derivative of v with respect to x when y is constant, which is equal to, again, just look here, v is given sine inverse of x by y. So we know that what is the derivative of sine inverse of x by y? It is 1 upon root over 1 minus x square. So in place of x square, it is x square upon y square. Again, derivative of x by y with respect to x is 1 upon y. Now, if we simplify it, 1 upon y, if we take the LCM of this part, it is y square minus x square upon y. So this y goes to numerator. Now we can write this can be written as 1 upon y whole divided by root over y square minus x square and whole divided by y. So this y and y will cancel, and we have root over 1 upon root over y square minus x square. And since we have to change y square minus x square as x square minus y square, so we have to take the minus sign outside. So this is the partial derivative of v with respect to x when y is constant. Now we want to find out the partial derivative of u and v with respect to y. Similarly, del u del y when x is constant, which is equal to, now the same thing over here, partial derivative of root x is 1 upon 2 root x, and derivative of y square with respect to y is 2y, derivative of x square with respect to y is 0. So we have this 2 will cancel. We have y upon root y square minus x square, and if we take the minus sign outside, so we can write down this y square minus x square can be written as x square minus y square. In the same manner, if you want to find out the partial derivative of v with respect to y when x is constant, what is v? V is nothing but sine inverse of x by y. So 1 upon, again, sine derivative of sine inverse of x is 1 upon 1 minus x square. So we can write down x square upon y square, and then again derivative of x by y with respect to y, as we have already seen in the previous example. What is the derivative of 1 upon x? 1 upon x is nothing but minus 1 upon x square. So here if you want to find out the derivative of 1 upon y, it is minus 1 upon y square. So here x minus x upon y whole square. Now if we again simplify it, what we are getting, x minus x upon y square, and the LCM of this is what? It is y square minus x square upon y square. If we take the root, it will become y. So this 1y and the 1y will cancel, and we have x upon y, x square minus y square. And since it is minus sign, so instead of writing root over y square minus x square, we are taking minus sign outside and we write down x square minus y square. So this 2 minus will cancel, and we have x upon y root x square minus y square. So we have already obtained the given four derivatives, del u del x when y is constant, del v del x when y is constant, del u del y when x is constant, and del v del y when x is constant. So let us try to take the left hand side and we will try to prove the uh, given result. So del u del x with respect to y is this, del v del y with respect to y is this. Similarly, del u del y with respect to del u del y when x is constant is minus y upon this, and del v del x when y is constant is this. So this are we have already obtained this one. Let us take the left hand side. What is the left hand side? Left hand side is del u del x when y is constant, del v del x when y is constant. So we have to prove this result. Okay, so let us take the left hand side. Now, what is del u del x when y is constant? This is x upon this, x upon root over x square minus y square, and del v del x when y is constant, it is minus 1 upon x root over x square minus y square. So this x minus x root x square minus y square into root x square minus y square is x square minus y square. In the same manner, right hand side is del u del x, del u del y when x is constant, del v del y when x is constant, and if we put the value of del u del y with respect when x is constant is minus y upon root over x square minus y square, and similarly del v del x when y is constant is x upon y into root x square minus y square. So this 2y will cancel, minus x upon again root x square minus y square into root x square minus y square is nothing but x square minus y square. So just look here, the left hand side is minus x upon x square minus y square, and the right hand side is also minus x upon x square minus y square. So clearly both are equal and whose value is minus x upon x square minus y square. Hence proved. Thank you.